Okay, physics fans, what does this image have in common with Welcome back, physics fans. And the answer, yes, is recoil, which is momentum. It really emphasizes a different part of the types of momentum. It's okay. So here we go. Remember, momentum was P equals mv. And that's why they have these memes out there. Anyways, let's get going on it. We were finishing up with number 6, and then we're going to start talking about the recoil stuff down here. So let's just finish up with number 6. For this collision below, we have two objects swinging towards each other. One is moving at 7 and it's 2 kilograms. The other one is moving at 2 and it's 1 kilogram for a head-on collision. And then after the collision, the 2 has slowed down from 7 to 1. We want to know what that velocity is of that guy. So we write down the momentum equation. That's what it says here. So the momentum before is equal to the momentum after. We have to say that because we're going to solve this question using conservation of momentum. Of course we are, because that's what this topic is about. But you got to say what you're doing. You have to write down which rule you're using. And how does it apply to this one? There's two objects, and it's one-dimensional. So m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. So the mass of number 1 is 2 kg times a velocity of 7. We're going to use this as positive velocity, and this is going to be a negative velocity. Because it's all vectors, it matters. 1 kg and negative 2 meters per second. And that equals 2 times 1 plus 1 times v. And that's v2 prime if we wanted to. That's that guy. So now it's just the only unknown in the whole thing. So this is the momentum question. This is what A is asking for. And now find the speed. Well, that's easy. This is 14, and this is negative 2 is equal to 2 plus, and we put that over there. This is going to be 12, and then subtract 2. This is going to be 10 is equal to 1 times V2. So V2 is going to equal 10. And the positive means it's also going to the right. Okay, because positive was to the right up here. So that's why that's the case, positive to the right. And if we want, we can put a prime there or afterwards, or the unknown. There we go. So back to recoil. We saw some videos back there about 3 minutes ago. And here it is. Let's just take a look at it. The diagram below shows two identical pop cans initially at rest, and explosive charges detonated between them, and the cans fly apart. So this is beforehand. What's the momentum beforehand? Everything's at rest. So mv, each of these have 0. So the total momentum before is equal to 0. So what's the momentum after? The momentum after has to also equal to 0, because they have to be equal. So what can be said about their velocities? Well, if they have the same masses, they have to have the same momentums. So their velocities have to be equal and opposite. If you want, we get 0, the before, is equal to after. So 0 has to equal m1 v1 prime plus m2 v2 prime. And we put them on either side. And we have m1 v1 prime, and that's negative because I brought it over here, is equal to m2 v2 prime. These masses are the same, so they cancel out. So v1 prime has to equal negative v2 prime. They have to be equal and opposite in direction. I think Sir Isaac Newton had something to say about that, and that's about what recoil is all about. You get an explosion between the gun and the bullet to push the bullet off, but it also pushes back on the gun. Gun recoil results from conservation of total momentum of the bullet gun system. The backwards recoil gun momentum balances the forward bullet momentum to maintain a total momentum of 0. The gun recoil actually has two primary parts: the primary recoil of the escaping bullet and the secondary recoil of the gas behind the bullet, because the gas is being pushed out as well. And if you don't think gas has momentum, how does a rocket go up in space and move in space? It's by shooting gas out. So rockets move really fast. So it does have a chance to do the momentum. Okay, example number 8. Here we go. A Winchester .308, or the .308 Winchester cartridge, launches a bullet of mass of about 150 grains, and 1 grain is 64.8 milligrams. Interesting. This is ballistics talk. With a speed of 282 feet per second. That's the old US version, and I've converted that 1 foot is equal to 30.5 centimeters. So we'll do some conversions here. We want to go into the meters, kilograms, and seconds units. Okay, we want to do the American units. The rifle has about a weight of 8 pounds, which is a mass of, mass, not mg, a mass of 3.8 kilograms. What will be the recoil speed of the rifle? So, momentum before equals the momentum after. So it's 0, because the momentum before is 0, is the mass of the bullet times the velocity of the bullet plus the mass of the gun times the velocity of the gun. Yeah, that's not too hard now. It looks like it's kind of simple. We just have to do some conversions. So the mass of the bullet times the velocity of the bullet. This is where we have to do all these conversions. The velocity of the bullet is equal to 282 feet per second. And so therefore, we want to convert this. Using this conversion factor, we want centimeters up top, because we want to get rid of the feet, so the feet have to be in the bottom. So this is going to be 30.5 centimeters, so the feet will cancel. But we want it in meters, so I'll put centimeters down below and meters up top, and 1 meter is 100. So let's take this 2820, multiply it by 30.5, and divide it by the 100, and we get 860.1. Ooh, 860.1 meters per second. That's more than 2 times the speed of sound. The speed of sound is about 330 or 320, depending on conditions. So yeah, definitely you won't hear that bullet coming. You'll hear it after. Okay, and the mass of the bullet is 150 grains, And we want to get rid of grains, so we put grains on the bottom. And it'll be milligrams, because that's what it says here, 64.8, sorry, is 1 grain. And we want to get rid of milligrams, and we want to put kilograms. Do you know the conversion factor there? 1 kilogram is 1,000,000 milligrams. Because it's 1,000 to grams, and then it's another 1,000 to kilograms, so that's 1,000,000, that's 10 to the 6th. So let's pull up the old calculator and get the mass of that. That's 150 times 64.8 divided by 1e to the 6, 1,000,000. So it's about 9 grams. You need about 100 of them to make a kilogram. So the mass of that is 0.00972 kg. So its momentum of the bullet is these two numbers multiplied together. So take the mass and multiply it by the velocity, and we get about 8.36. kilograms meters per second, because that's MV. So if that's the mass of the bullet, if that's the momentum of the bullet, that is also equal to the momentum of the gun. P of the gun has to be the same, and that's equal to the mass of the gun times V, and this is 3.8 kg. So we divide this by 3.8, and we get the velocity of the gun, velocity of the Winchester, is 2.2 meters per second. So that's firing backwards into your shoulder at 2.2 meters per second. A 3.8 kilogram rifle. That's why it hurts. And that's why, let's just take a look at this and draw big arrows. The center of balance of the gun would be about there. And this explodes and pushes the bullet out. That same force is here. But it's not there, it's up from the center. So it's going to cause a torque, which is going to lift the gun up around this pivot point. Because that's the pivot point. You're pushing this way, which is going to also help it torque that way. So that's why when a gun fires, you get the nozzle going up, or at least in this one in the video, we saw it go spiraling back, all the way back. Cool. Anyhow, there we go. Let's see if there's anything else. Some theory here to end off this lesson. The happy and sad balls here have the same size and mass and appear identical. Okay, so there's happy and sad. Except when they're dropped, the happy one bounces, so it goes down and goes back up. The sad one goes bloop and sticks. It goes splat. If we throw these balls at a block with equal speeds, which one is more likely to knock the block over? The happy one, the sad one, or equal? Think about it. Think about it. please apply all the concepts that we've done. We've done a lot of concepts here. We've done impulse is equal to the change in momentum. And that's going to be a force times the time is going to be m times the change in velocity. Important. That's the big thing for this chapter. Well, no. That's the big thing for one object. This is the one object one. And if there's two objects, each one does this. And for the system, we use the P before equals the P after. And then it could be three objects, M1, V1 plus M2, V2 plus M3, V3 is equal to M1, maybe 1 and 2 combined together, M1, V1 plus M2, V2 plus M3, V3. And if they stick together, the next line, you can just go M1, V1 prime plus M2, V2 prime plus M3, V3 prime. Oh, these are not primes, these are befores. And that equals, maybe these two guys stick together, and this guy stops. Who knows, right? If they stick together, M1 plus M2, might as well make it one mass. And they're going V, and I'll call it 1, 2 prime. And maybe this guy stops, so plus 0. Who knows? But you write down this, you write down this, and then you start making it how it applies to this one. Start plugging in the numbers and away you go. So this is for multiple objects, collision, and this is for single object. And each of one of these multiple objects you can look at just singly as well, because if you have the point of time of impact, then you can do this for each of them. And you know that if one goes up, then the other one has to go down and stuff like that. Anyhow, 60 minutes into the video, let's just kind of stop here and come back to the next one to see if you could figure out which one's is more likely to knock it over, or are they the same? Really good question. It's often done on a test. Think about it. Comment down below, please. Comment down below on what you think is going to happen. All right. Thanks. Like, subscribe. Smash that like button. Smash that subscribe button. I like you guys. I love you guys. I miss you guys. Talk to you soon. Bye-bye.